In this video we are going to learn about ores, what they are and how we extract minerals from them. Ores are rocks. Okay, it's not really as simple as that. Ores are rocks that contain minerals. Minerals are the sparkly bits you see in some rocks, and they are valuable because most things you use every day contain one or more elements extracted from an ore. Minerals are naturally occurring. Each one has its own definite composition and arrangement. There are lots of different minerals. Some are uncombined elements, such as aluminium or gold, or they can be compounds. Hematite contains iron in the form of iron oxide. Malachite contains copper. Cinnabar is a mineral that contains mercury. There are also non-metal minerals. Quartz contains silicon, and limestone contains calcium. But today we are going to be talking about extracting metals from ores. Extracting metals from ores can be expensive. A high-grade ore is a rock that contains metals in large enough quantities for the extraction process to be profitable, whereas a low-grade ore contains metals in smaller quantities. They are not very profitable to extract, or maybe not financially worth extracting at all. To be useful, the metals will need to be extracted from its compounds. How this is done depends on their reactivity, or how easily the metal atom loses its outer electrons and combines with other elements. More reactive atoms displace less reactive atoms from their compounds. Metals are often put into a reactivity series. It's just a list of metals in order of their reactivity, but it helps us to predict what method of extraction is best for a particular metal. At the bottom of the series are the least reactive elements, silver and gold. These are often found uncombined as elements. This is also called in their native state. Zinc, iron and copper are more reactive and are found combined in compounds with carbonates, sulfides and oxides. They can be extracted from their compounds by heating with carbon. Although it is not a metal, carbon is often inserted into the reactivity series as a guide to show which metals are more and which metals are less reactive than it is, because only metals less reactive than carbon can be extracted by heating with carbon. Above carbon are listed the metals that are more reactive. Potassium is listed in the top position of the series. The metals that are more reactive than carbon are extracted from their compounds by electrolysis. So how do we use the reactivity series? Hematite is an ore containing iron oxide. Iron oxide is a compound containing iron and oxygen. So what method do we use to separate the iron from the oxygen? Iron is below carbon in the reactivity series, and so can be extracted from the compound by heating with carbon. Malachite is an ore containing copper carbonate, and as copper is below carbon in the reactivity series, it can also be extracted from its compound by heating with carbon. Bauxite is an ore containing aluminium oxide. Aluminium is more reactive than carbon and is therefore above carbon in the reactivity series, so it cannot be extracted from its compound by heating with carbon. Instead, it is extracted by electrolysis. Electrolysis uses electricity to split the compound. You will need to watch our earlier video on electrolysis for more information about the process. But you do need to know in this section that the electrolyte used is aluminium oxide and cryolite. The reason that cryolite is mixed with the aluminium oxide is to reduce the melting point of aluminium and therefore reduce the cost of the process. If you are taking the higher T exam, then you need to know about biological methods of metal extraction. High-grade ores are becoming more difficult to find, and therefore more low-grade ore is being used. This makes the traditional method of extraction too expensive. Bioleaching is one of the alternatives that can be used to extract copper, nickel, cobalt, and zinc. All of these metals are below carbon in the reactivity series. Bacteria is grown on the low-grade ore. The bacteria produces a solution that contains copper ions. The solution is called a leachate. Bioleaching has a number of advantages. It can be used on lower grade ore. It also does not produce the polluting sulfur dioxide gas that extraction by heating with carbon potentially produces. And you don't have the expense of heating the metal compound. However, bioleaching has a disadvantage of being a very slow process and can potentially produce sulfuric acid, which can be damaging to the environment. Once the leachate has been produced, scrap iron is added to it to produce copper atoms. Iron can be used in this process because it is more reactive than copper. The copper can then be purified by electrolysis. Another example of a biological method of metal extraction is phytoextraction. Plants are grown on contaminated soils and absorb the metal compounds from the soils. The metal is then extracted by burning the plant. If you found this video useful, then please subscribe to our channel.